Hello everyone, welcome to Advanced Cybernetic Systems Development Learning Activity 5, and we're going to go jump into computational learning theory. Man, say that fast a few times. Okay, so computational learning theory. Alright, so what is computational learning theory? Well, it's in computer science, computational learning theory, or just learning theory, it's a subfield within artificial intelligence. And so what we're going to do and what we're going to talk about today is the fundamentals, the really kind of the unsupervised, supervised, reinforcement, and deep learning. And so I'm going to talk through visually what that looks like through a couple examples of what each one does and how it kind of operates at a really basic level. And then we'll kind of scale that up as we move along. So what you can expect in this course is that as you're moving along, the lectures are going to give us some machine learning fundamentals, and then we'll start to run through that. And then as we get into, on the lab side, we'll be working with our microcontroller on the bare metal side and doing, I will be pulling in some examples as we move along. And there might be some stuff on the Python side. I'm not going to expect you to do any programming on that because I want us to focus on the bare metal. But there might be some Python programming just to show you some differences between stochastic programming, stochastic versus deterministic systems, and the differences there. But for the most part, what we're trying to teach here is going to be some of the cognitive processing that you're going to see in the fundamentals and this machine learning fundamentals that you're going to see in the lectures. And then on the labs, we're going to focus on, of course, the bare metal programming, C++, and then integrating machine learning onto the device that we'll be using. Okay, so let's jump into unsupervised learning. So unsupervised learning is like when I don't have anything other than the data that's presented to me, and I'm not using training data, and I'm going to take this data and I'm going to cluster it. I'm going to put them into groups, and that's essentially all unsupervised learning data. So when I say unsupervised, it means that there's no prior training data used in the output. So in other words, I'm just looking at the input data, and then I cluster the data based on just what I see, based on the input data by itself. In other words, I don't have any pre-data that I give to it. In other words, this what we're looking at here, if I created a model that said, hey, I'm going to pre-label the apples, pre-label the bananas, and pre-label the peaches, and then I'm going to run that pre-trained data through I'm going to run that through my model, and then I create an output, then that would be what's called supervised learning. But this is unsupervised. I don't have any training data that I'm working with. So it's just input data, take input data, and give me, make some sense of the input data that I gave you. In this case, it's an unsupervised learning. Now let's take it and let's look at actual textual data, not visual data. So if I had something that was B, O, and X, I have these boxes, and so I have this string of letters that's just kind of in this randomized, what appears to be X, O, B, X, X, O, 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 B, B, O. So it just goes through, right? Well, if I said, okay, my sample size is going to be small n, little n equals 77. So, okay. And then what is the pattern? So, well, we can count them, and then that gives us a basic pattern. Well, I have B equals to 24, O equals to 34, X equals to 19. And if I plot that out, I start to see a pattern, right? And so this is, by definition, unsupervised learning. So we've just done something very basic. We went through a very, very basic counting sequence, and then created a unsupervised learning by just doing just a basic counting algorithm to do unsupervised learning. That's it. So that's what we've done. We've just counted them, and we've got a pattern. Now, let's move over to supervised learning. So supervised learning is, I kind of let the cat out of the bag a little bit earlier, in that if I take the input data and then I say, hey, I pre-label it, and I move that into the model, and then I run. So then that model then becomes something that is now pre-labeled because I've clustered it and labeled it. So I take the labels, and then I take that as training data, and then I move it through another model and say, I say, what's gonna happen next, or what's gonna grow next? That would be supervised learning. So that's an example of, okay, it's a forecast. Predict what happens next based on the pre-trained data that I gave it. Now, using supervised learning on our data example, so if I said XOB and I'm taking the same string, and then, but what I'm doing is I'm saying I'm going to create an algorithm. I'm going to use a moving average. So instead, I'm going to take the count data that I gave it, right? So our counting algorithm that we had, and then I'm going to say, okay, take that counting algorithm and add another algorithm on top of that called a moving average, and then give me a movement of that. But I have to do something to that data to create the average, because this is textual information. I have to vectorize the data. And when I say vectorize, I have to take the categorical data and I have to give it a numerical value. So in this case, I arbitrarily say I'm going to make B 302x1. And that's an arbitrary number that I give it. But that allows me to do a forecast and then predict what is going to happen next in the sequence. Because I vectorized it, then I can apply a moving average to the vectorized data. Remember, I'm going through some steps here. And then from there, I get a forecast. That's the prediction. So that's supervised learning. And it's as simple as that. It's pretty straightforward. I mean, it gets more complicated, of course, when we're talking more data. But in a nutshell, this is a lot of how supervised learning algorithms work. I'm just oversimplifying it, but to a certain extent, this is what's happening. Okay, so let's take a look at the data and what's happening. So what's happening, and I took the string. So right here in the middle, this is the textual information, and this blue part is the prediction. This green part is the training data. So then what I'm doing is I'm taking the moving average and I'm applying it each time going forward. And so what happens is when I take that moving average and I move that moving average forward through the data, I'm actually starting to incorporate some of my predicted values into my training data and incorporating that into the moving average that influences what my future prediction is going to be. So that is essentially what we're doing. This bottom line right here, that's the vectorized. That is the vectorized data. So when I take that, I'm taking the categorical information here. I'm assigning a value to it, and then I'm creating a prediction off of that, because then I can apply math to it. I can't apply math to the textual information, but I can apply math to the numerical information, and that is hugely important to us. And that is a very large part of how natural language processing engines work. They have a vectorization routine that goes through this process of taking the textual information that you see and then turning that into a numerical form, and then that I can do number crunching on it computationally within a computational engine. Okay, so that brings us to reinforcement learning. So what is reinforcement learning? Well, there's a reward system. I usually have an agent that operates within an environment, and then there's a reward that happens within that reinforcement. Or I'm sorry, that affects the reinforcement. So reinforcement learning, in this case, if we take the same data stream, again, we're not changing anything, but what I'm going to do is I'm going to add another algorithm. So I'm going to say it's still the same data, but I'm going to do an algorithm with a moving average. Again, we did that last time, but now I'm going to add another one that I'm going to add a reinforcement. I'm going to do the same thing I did before, where I vectorize the categorical data. But then what I'm going to do is I'm going to selectively reinforce one, and negatively, I'm going to positively reinforce X's, and this is just an example, and then I'm going to negatively reinforce the occurrence of B. And so what ends up happening is what's going to happen next in the sequence for the next 10 instances of X. and you'll see what happens is our curve changes, right? So I negatively reinforced our prediction by doing that. Now, how did I do that? In the data sequence, right, what I did was I said anytime you see a 1, again, we're going to positively reinforce x's and negatively reinforce the instance of b's. So then what happens is it negatively impacts our moving average. So I'm reinforcing, I'm rewarding x's, but I'm negatively impacting it by a reverse reward, right, for b's. So then that's what ends up happening is I get this movement and this shift of the prediction to go a different direction. And this is the basis of reinforcement learning. Okay. All right. So deep learning, we're going to, on the deep learning side, it's, when we say deep learning, it's not, we're talking about artificial neural networks, and there's a lot of them. Generative adversarial networks, GANs, convolutional neural nets, deep convolutional neural nets, recurrent neural nets, you name it. There's a whole bunch of neural networks out there, and they're just expanding, right? Deep learning has gotten so, especially when we talk about large language models, large multimodal models, I mean, it just has gotten to the point where these models are so large, and the architectures within them are so complex that when we, as humans, create them, we largely don't understand how we have an estimation of what happens. It's kind of like the human brain, right? We know the big structures. We know that, like, hey, processing happens here. We know the vision processing in the occipital lobe. You know, we know that Broca's areas within the brain is motor function for the mouth, Wernicke's for auditory, and so that we can understand and comprehension. There's just all different kinds of things that we know the structures, but when you go dive deep down, we don't know how the neurons are firing. I mean, well, we know how the individual neurons are firing, but there's a we know the micro and we know the macro, but there's a meso layer in the middle that we have trouble with, and that is what the same thing is happening with regard to these neural nets that we create. So when we create a large language model, we at a high level know what's going on, and we know at a low level what's going on, but we kind of don't know at a meso level what's going within the circuitry of the neurons, that the big mass structures within it, and how things have developed. It's kind of like the Wild West right now. It's pretty wild. So, but when we talk about deep learning, so ultimately when we're talking about deep learning, we're talking about anything that's a neural network. So it's a class of algorithms that are neural networks, and they are modeled after neuronal networks within that are biologically inspired neural networks. So that's your deep learning, right? And so when you see that, you just know that we're talking about, again, neural networks. All right, that's all I've got for this lecture. I hope this was informative from just a kind of, again, we'll keep revisiting these. This isn't the last time you're going to see this. So we're going to keep coming back to revisit each one of these. Ultimately, what we end up doing, because there's just not, I'm hoping that we can do multiple projects, but we'll work our way up into getting competency with the Arduino, and then we're going to add in, we are for sure adding in a machine learning, I guess you could say, capstone to this course, where we'll get comfortable with our controller, we're going to work on different projects, and then we're going to work on some probabilistic programming using the Arduino programming language, and then we'll get into doing some fun stuff in that regard. But we will be doing a machine learning model at that point. That's all I've got for now, and we'll see you in the next lab.